Alright class, welcome to the first video of the school year. Super exciting. I think watching videos is a little bit easier than doing homework at night, and then when we get to class we'll work on stuff and figure all this stuff out together. So, this first video, we're starting off with evaluating functions. Now, I'm thinking that we've already done some of this when we were doing average rate of change, secant line, stuff like that. We know that when we evaluate functions, this f of x part is kind of like the y, and then, well, whatever is inside the parentheses is our input. So in this case, all we're going to do is start rewriting the function, but we plug in 2 for x. Alright, as we clean this up, we say that f of 2 is now 3 times 4 plus 10, or 12 plus 10, or 22. Alright, so that's a nice one. We give you a numerical input, you get a numerical output. For this next one, for b, it's a little different. Alright, now all we're saying is that instead of inputting an x into the function, we're going to input negative x. So let's see what happens. Well, again, we just start rewriting, and we replace every x with negative x. Alright, we start to clean up. Well, we know that a negative value squared is just the positive value squared. And then 5 times negative x, well, I'm just going to change this right now to negative 5x. So we can finish this up by getting rid of those parentheses. I guess I could have done that last step, but here we are. Alright, makes sense? Not that bad. When we look at C, again, it's the same exact thing. We just have to be careful that we replace the x in the original function completely with 2x. So, 3 2x squared plus 5 times 2x. Let's see here. F of 2x. We'll keep the 3. We have to square everything in here. So 2 squared is 4. X squared is x squared. And now let's see. 5 times 2x, we have 10x. Last step. Distribute. So we have 12x squared plus 10x. And that would be an acceptable answer. Alright. I kind of feel bad. I should have been boxing these. Of course, you don't have to, but just for my notes' sake, I am going to make sure I mark that these are my final answers. Okay. Last one. Probably the trickiest one, but something that you guys can do. And this is definitely something that's going to come, or we're going to see again in a little bit. So this skill, when we have a quantity being plugged into a function, is something that you guys need to practice. So let's see how this looks. The first step should be nice and easy. Alright, we just replace. What did we do? We just replaced the x of the original function with our quantity x plus 2. Now, we have some work to do. Of course, this is still going to be f of x plus 2. You have options here. You guys can say, well, I have x plus 2 squared. I know that this is going to be the reverse of a perfect square trinomial. So you could use a pattern to distribute this. The other option, and what I'm going to show right now, just so you guys remember, is you can always rewrite and then expand. Alright, so this one's going to definitely have a little more work than the last few. Let's see what happens. I'm going to keep my 3. I know that I'm going to have x squared. I know that I'm going to have 2x. I also know I'm going to have another 2x. So 2x plus another 2x is 4x. And then lastly, 2 times 2 is 4. And then this one's nice and easy, 5x plus 10. Ooh, I went off the screen a little bit there, guys. I'm sorry about that. Am I there? Okay, there we go. Sorry about that. All right, now we're ready to clean this up. F of x plus 2 equals, all right, we have to distribute everything here. So 3x squared plus 12x plus 12 plus 5x plus 10. And let's see here, last line, f of x plus 2 equals, well, this is my only term with an x squared, so this is going to stay. I have a 12x and a 5x, so 17x, and then I have a 12 and a 10 for my constants. So, my final answer for f of x plus 2 is 3x squared plus 17x plus 22. Alright, again, if we did not quite get this, go back, re-watch. This is something you are going to need in a little bit on our next page actually. Okay, so make sure to get that down. Alright, let's move on. Let's take a look at something like example 7 and letter E. Alright, so again, we have a new function, 2x squared minus 4x. Please note, this is super important, this 3 is where? Is it inside of the function? Is it the input? Or is it just a value being multiplied by the function? Hopefully you said the latter. Okay, this 3 is just going to be multiplied by f of x, right? Just like that. It might help, and maybe I should do this, right? It's just 3 times f of x, so then I just have 3 times whatever f of x is. And now it's as simple as distributing 6x squared minus 12x. And we're done, because we wanted to know what 3 times f of x was. So very nice. Alright, if we take a look at something like f, well, this one's slightly more difficult, but what you notice here, very nicely, we have this f of x again. So again, what are you going to do? You're just going to completely replace it. We know that f of x is 2x squared minus 4x. Now, we do have to add f of 5 to this function, which means I am going to, actually let me change colors here. I'm going to say f of 5, so I'm going to add, and actually let me be exact here for you guys so you know what I'm doing. So I took my blue parentheses and I replaced inside the blue parentheses. Now I'm going to do the exact same, but now with the red. So 2, and I'm going to replace now 5 squared minus 4 times 5, something like that. Alright, so as we start to clean this up, well, this is just going to stay. This I can kind of clean up. What do I have here? 5 squared is 25, 25 times 2 is 50, and 4 times 5 is 20, something like that. So let's change colors again, and this time, remember, we have f of x plus f of 5 equals, well, let's see, what do we have? We have 2x squared, we have minus 4x, or negative 4x, and right here we say we have plus 30. So our final answer is right there. Not that bad, right? Not too bad. Okay, we're getting there. We're moving right along. This next example is a nice example where we're starting to use some real-world situations, and we're going to use our algebra to solve. And again, this is all helping us get more comfortable using functions and function notation. So what do we see here? we have a rock that falls from a height of 15 meters. The height h in meters after x seconds is approximately h of x equals 15 minus 4.9x squared. So things to definitely take note of. Usually we say what? That this piece over here is our y. Well, in this case that means that our height is kind of like our y value, and then our x is going to be time. Alright, and I couldn't put an x there, but it's already an x. So there we go. So let's read through a problem, something like letter A, and see what it's really asking. Alright. What is the height of the rock after 1.1 seconds? Alright, this is a classic situation, guys. You have to figure out what you have. Hopefully we all understand that if I'm telling you that we want to find a height after 1.1 seconds, well, that means you have time. Time is known, which means, of course, then height is unknown. That's good. That's helpful. That means that we are going to be plugging in something known, a time, and getting out our unknown. So what does that look like? Well, I know that I'm trying to find the height at a time of 1.1 seconds. So I'm going to plug 1.1 into my function. Alright, that's all I did. I just replaced my x with 1.1. And now, guys, you can go straight to the calculator. You can do this in one line if you want. You don't even have to show me much work. I would just do 15 minus 4.9 parenthesis 1.1 squared. And I got that the height at 1.1 seconds is approximately 9.07. And then just be careful. We see that height should be in meters, so m, or meters. Make sense? Not that bad. Not that bad. What happens when we look at something like letter B? Well, now we know the height, and we're looking for time. Alright, we're looking for time. Well, if we know the height, that means, guys, we completely replace the left side of the function, okay? We don't do h of 10. That's not what we're doing. That would say that we're finding the height at a time of 10 seconds. We know that the height is 10, so I completely replace the left side of the function, or equation, I guess in this case now, with a 10. Just like that. Now we solve. Personally, when I see something like this, if I don't have multiple x's in different terms, I would just use the square root method, which means I want to solve and I want to get x squared alone on one side, which means what am I going to do? I'm going to move this 15 over. So I have negative 5 equals negative 4.9x squared. And then I'll come over here and I will do negative 5 over negative 4.9 equals x squared. At this point, you can show me whatever work you want. If I see this, I'll know that you're on the right track. You honestly could plug this right into the calculator the way it's written. Or I guess actually, let me square root first. Right? I want to square root both sides. But you can actually do, I don't know if you guys can see this. Oh yeah, you can. Square root, fraction, negative 5 over negative 4.9. Whoop. 4.9, hit enter, and there is the answer that we want. Now, you might be asking, but Mr. Rabens, don't we always say plus minus? I hope you guys understand that we can't have negative time, right? So yes, while if this was just an algebraic, or just a simple algebra problem, I would need both. Because of the real-world spin on it, we do not want that negative value. We just want to say x is approximately 1.01 seconds. And I should box. Alright. Okay, almost done with this page. I'm going pretty long, shoot. Okay, the next question, when does the rock strike the ground? You guys need to be able to understand what I mean by that. When I say when the rock strikes the ground, well, this question when, this means I don't have a time, right? That's an unknown. Well, what the heck do I mean by the rock strikes the ground? What is the height when a rock strikes the ground? If you said that the height will equal 0 meters, well then you're right on it. Okay, that's exactly what we do. When the rock strikes the ground, the height will be 0 meters. So it's the same thing as letter B, except now we use a 0 instead of 10. So 0 equals 15 minus 4.9x squared. And then in this case, I'm just going to move the 4.9x squared over to equal 15. And then I'll divide both sides by 4.9, so I'm left with x squared equals 15 over 4.9. We square root both sides, and we should get, let's see here, 15 over 4.9. Let's go back to blue. That x is approximately 1.75 seconds. Okay? So there's that. That was a lot of work on evaluating functions. As we move to the next page, I want to kind of let you guys know this, what we're doing now, this difference quotient that you see at the top. This is a calculus idea, okay? We are not going to be doing a ton with this difference quotient except for practicing it so that you're ready for it when you see it next year in a calculus class. All right? And again, it's a good place to learn it because what do we see here? Function notation, evaluating functions. All right, so that's kind of why we're going through this now. And hopefully we'll be building on this skill throughout the year so that you're completely ready for it next year. All right. The first thing that we need to do is we need to clean up the f of x plus h piece. Okay, that's the first thing we're going to do. That can be, and that usually is the messiest part. So that's what I want us to take care of first. Sorry, I'm a little bit off the page. Let me move it back. There we go. Sorry about that. All right, so that's what we're going to do first. Well, we notice we have a function, f of x equals x squared plus 5x. So let's see what happens when we plug in x plus h. All right, f of x plus h equals x plus h squared plus 5x plus h. All right, well, this definitely needs to be cleaned up. So let's keep going. We can do it a couple of ways, but I'd say the easiest way and the way that you probably remember the most is to just write it twice. And now we FOIL. All right, so we have x squared, and then we have an xh and another xh. So we have two xh, and lastly, h squared. Here we have 5x plus 5h. And really, if we notice this is an x squared, I don't see any other x squareds. Nothing's really going to clean up here. So for right now, we are going to say that f of x plus h is all of this. X squared plus 2xh plus h squared plus 5x plus 5h. All right, so now notice, guys, we have the first piece of the difference quotient. So what do we do now? Substitute into dq. I guess I'll call that a formula. All right. So now, and I'll stay in red for this part, I'm going to completely put this into the difference quotient formula. So I have x squared plus 2xh plus h squared plus 5x plus 5h. Oh my gosh. And what I'm going to do now is I am going to subtract f of x. So I'll box this, I'll box this. I am going to now plug in x squared plus 5x. And this should all be over h. Alright, the last thing that we're really going to do, guys, we simplify. I'm going to say clean up. I tend to say that a lot. We're going to clean this up. Alright, by that I mean, when I go through this, oh, am I off the page now? Sorry about that, guys. Let me move down. Sorry. So number 3, simplify. X squared plus 2xh plus h squared plus 5x plus 5h minus x squared minus 5x all over h. Well, this is really nice, and this means that you're doing something right. Boom, boom. What else? Boom, boom. Okay? If you don't get things canceling out, then you did something incorrect. So because canceling is happening, you're good. You know you're good. Let's keep going. 2xh plus h squared plus 5h all over h. Well, what do you guys notice about the numerator? I see an h, I see an h, I see an h. That's good. Okay? If you can factor out an h, once again, smiley face. Alright, that's what we're going to do. So, h, 2x plus h plus 5 all over h. And what do you think I'm going to do again now? If you can reduce, sorry, I need a question mark there. If you can reduce, one more smiley face, and we know that the difference quotient is 2x plus h plus 5. Alright, now I know that my video is starting to get a little bit long. If you think you completely understand this concept, feel free to pause or stop, and then we can just work on this tomorrow in class. However, if this was something that you didn't quite get, please, please, please stick with me for the final example on the next page. Alright, so as we move on to this last page, we have a new function we can see. And let's just remind ourselves of what the difference quotient formula was. Okay, we know that the difference quotient is going to be f of x plus h minus f of x all over h. Alright, that's what we're looking for. So again, remember, first step, worry about the difficult part, the f of x plus h. So, let's see here. F of x plus h, so I'll have 2x plus h squared minus 3 times the quantity x plus h plus 1. Alright, we start to clean this up. 2, and I'm going to write it twice, minus 3x plus h plus 1. Okay, what do we have to do here? We need to distribute or FOIL to start to clean this up. So 2, I'm going to have an x squared, I'm going to have an xh and another xh, so 2xh plus h squared minus 3x minus 3h. Be very careful when you're distributing. You have to distribute correctly. So we're getting there. We're getting there. We still have a little bit more work. 2x squared plus 2, oh, sorry, I messed up, plus 4x 4xh plus 2h squared minus 3x minus 3h plus 1. Does anything reduce or cancel or combine? No. Okay, nothing combines here. So this is what we are going to plug in, back in, I should say, into the difference quotient formula. Alright? So now, again, we look back up at the top. We know that this is the first piece, so I'm going to rewrite all of this, and maybe I'll do this. Okay, this was the f of x plus h. Now it's the substitution part. Alright, so let's go and do it. We have 2x squared plus 4xh plus 2h squared minus 3x minus 3h plus 1. And then what do we have to do? It says we now need to subtract f of x. Okay, we need to subtract f of x. Now I'm going to change color. Hopefully you guys see what I'm going to do. I'm just going to immediately subtract every piece from this. Instead of writing it in parentheses and distributing, I'm just going to all at once, I'm going to say if it's telling me to subtract this function, well then I need to subtract every single piece. So minus 2x squared minus negative 3x is actually plus 3x, and then minus 1. Alright? And now we get to have some fun. My favorite thing in math, crossing stuff out. Oh, what did I forget? Bad teacher here. What did I forget? Very sorry about that, guys. Absolutely needs to be over h. Alright, so now we can clean this up. We know what's canceling out. We can rewrite this as 4xh plus 2h squared minus 3h all over h. And what do we know? We know that we're going to factor out an h. Let me move down a little, sorry about that. 4x plus 2h minus 3 all over h. Cancel. So we know that our difference quotient here is 4x plus 2h minus 3. Now, if you're completely, and I get it, if you're wondering what the heck am I doing here, I just need you to trust me. This is going to come into play quite a bit in calculus. Really what we were doing here, and the whole formula of the difference quotient is coming from average rate of change. What we're really doing is we're saying that we have 2 points. We're having a point x plus h, comma, f of x plus h, and we have another point x, comma, f of x. And what are we doing? We're just plugging it into the average rate of change. We're finding the slope, basically, or the average rate of change. Now, what we care about and why it becomes big in calculus is we start to work when h approaches 0. That's when we start to figure stuff out about not average rate of change, but instantaneous rate of change. Again, I don't want to get too far into this because we are not going to be doing that in pre-calculus. However, I know a lot of you guys like to know why the heck you're doing stuff, so I just wanted to give a brief synopsis on that. Alright, so that's it for our first video. I know it was super long. If you're still with me, thank you. I hope everyone is understanding this decently, at least to the point where we can work on it together in class. Alright, have a good one. See you next time.